An inscribed angle is an angle whose vertex is on the circle. So if you look at the diagram, since vertex B is on the circle, it makes angle B an inscribed angle. And the theorem states that the inscribed angle is half of the intercepted arc. So here is the intercepted arc, AC. It's the arc that's between these two chords if you extend it out. So whatever arc AC is, angle B is going to be half of that degree measure. So number 1 says the measure of arc RS is 82 degrees, and we want to find the measure of angle RTS. Well, you can see that the vertex of angle T is on the circle, so this is an inscribed angle. We're taking half of that intercepted arc. Again, it's always the arc that's between these two chords if you extend out. So if I take half of 82, I would get 41 degrees. Number 2, we have to find the measure of arc BC. Well, angle A is an inscribed angle. The vertex is on the circle. We know that the angle is 32 degrees, and the angle is half of this intercepted arc. Well, it's really the reverse of number 1. If I have the angle, I would just have to double it to get the intercepted arc. So it's going to be 64 degrees. And number 3, this time, read carefully. It's the measure of arc ABC is 150. So from A through B to C, this arc over here is 150. And we have to find the degree measure of angle ABC. Well, ABC is an inscribed angle because the vertex is on the circle. So if I extend out the two chords, it's half of this major arc AC. The arc that I'm highlighting. It's always the arc between those two chords extended out. Well, we don't have that arc right now. But if we know that this arc over here is 150 degrees and a full circle is 360, what we can do is 360 for a full circle, subtract that 150, and we'll get 210. So that arc in purple or pink, I don't know what it is, but that arc over here that I've highlighted is 210 degrees. Then if we want to find the measure of angle ABC, it's an inscribed angle. I take half of that intercepted arc, and half of 210 is 105 degrees. So there's our answer, 105. Number 4, the measure of angle ACB, this inscribed angle, the vertex is on the circle, is 38 degrees, and we want to find the measure of angle AOB. Well, angle AOB here, that's a central angle, and if you remember, a central angle is the same degree measure as the intercepted arc. So I extend this out. That means that this angle is the same as arc AB, so we really have to find arc AB first. Well, the inscribed angle is 38 degrees, and the inscribed angle is half of the intercepted arc. So if I double the 38, I would get 76 degrees for that arc. And since the central angle is the same as that intercepted arc, the central angle, angle AOB, would be 76 degrees. Number 5 is going to go with something that's on your chart where it lists the theorems. It says, given the diameter AOC, and that's important because then you know that this arc right here is 180 degrees. It's going to be a semicircle. We have to explain why the measure of angle ABC is 90 degrees. Well, right here you can tell that angle B is an inscribed angle because the vertex is on the circle. So if I extend out the chords, it's going to be half of the intercepted arc. Well, this intercepted arc is 180. So if I take half of 180, I get 90 degrees. So it forms really a right angle at angle B. Now, how do we say that? Well, it's going to be, if you look at your chart, it's going to be the very first theorem. An angle inscribed, because angle B is an inscribed angle here, right? An angle inscribed in a semicircle, because it really opens up to a 100-degree arc there. So an angle inscribed in a semicircle is a right angle. An angle inscribed in a semicircle is a right angle, and that's how we know that it's going to be 90 degrees. Number 6, we have a quadrilateral inscribed in circle L, so that means each of the vertices are going to be on the circle. If the measure of arc AB is 132 and BC is 82, find the measure of angle ADC. Well, angle ADC is an inscribed angle. The vertex is on the circle, so I'm just going to, best I can here, try to extend the chords that form the angle to see what arc we have to take half of. So we have to take half of the intercepted arc, which is from one end of the chord all the way to the other. So that would mean this whole arc that I've highlighted in green. So what we have to do is add 132 degrees and 82 degrees. And when you add those two arcs together, you get 214. So that's the degree measure of that full arc in green. But we wanted to find the measure of angle ABC, and this angle is inscribed. It's on the circle, so I would take half of the intercepted arc, and half of 214 is 107 degrees. Number 7, we have to actually draw the diagram ourselves. It says we have an angle inscribed in a circle that's 80 degrees. What is the number of degrees in the intercepted arc? So we're going to draw an inscribed angle. So put a vertex wherever you want on the circle, and we're just going to extend out to form two chords. And it says the angle is 80 degrees. What is the degree measure of the intercepted arc? Well, an inscribed angle is half of the intercepted arc, so the arc would be 160 degrees. Really, we have to end up doubling it. Okay, a couple more. Find the measure of arc WV. Okay, here's WV. Well, there's a couple ways you can do this, actually. One thing you can do is, I see that this angle V is an inscribed angle. So this 40 degrees is half of the intercepted arc, so it'd be half of WX. So really I have to double it, so this arc is 80 degrees right here. And you can tell because this chord goes through the center of the circle, this is really a diameter, so it's splitting the circle in half. So that means that this entire arc here is 180. So if I just do 180 degrees, I subtract the 80 that we have, and you get 100. Again, there is a different way to do it using the triangle. I just didn't happen to do it that way. Okay, moving right along. We have to find the measure of angle A. Well, angle A is an inscribed angle, right? So if I extend out, it's half of the intercepted arc, which I'm going to highlight. So it's half of this arc in green here. Well, we have to first find that arc. So if we take a full circle is 360. So if we take 67 and 135, we subtract that from 360, we get this arc to be 158 degrees. And since angle A is an inscribed angle, I would take half of that. So angle A is 79 degrees. And we're going to do one more problem all the way in the back, number 15. We have to identify one pair of inscribed angles that are congruent and explain why they are congruent. There's two different answers here. I'm just going to pick one of them. If you look at angle F is an inscribed angle, right? And it would be half of the intercepted arc. It would be half of DG. Same thing with angle E. Angle E is an inscribed angle, and this angle also would be half of that same arc, DG. Since we're taking half of the same arc, like for example, if this arc was, I don't know, looks maybe around like 160 degrees. If I take half of 160, half of 160, I'm getting 80 degrees for both of those angles. Okay, so I'm going to say that angle F is congruent to angle E. And by the way, the other pair you could have done was angles D and G, because those would both be half of arc FE. So they just have to open up to the same arc. So those two angles are congruent, and we have to explain why they're congruent. Now there is a theorem that goes with this. If you go to your chart, it's theorem number 2, and it says that if two inscribed angles, it's always really important to state what kind of angles they are. So if two inscribed angles intercept the same arc, and you can get specific and say they intercept arc, what was it, DG. But if two inscribed angles intercept the same arc, then they are congruent. And most of the time in these questions, when you have to explain, you're just going back to one of the theorems from your chart. That came out weird. Then they are congruent. Okay, there we go.